Hi everyone, in this video we will build the foundation of mass balance in mineral processing, the two-product formula and the calculations that come from it. Everything starts with one law: matter can neither be created nor destroyed. So for any unit at steady state, what goes in must come out. Input equals output. That's the whole idea. Now picture a simple separator. One feed comes in and it splits into two products, a concentrate and a tailings. Watch the grains. The feed is a mix, valuable mineral in blue, gangue in gray. The separator sends most of the valuable mineral to the concentrate and most of the gangue to the tailings. It's never perfect. A little of each ends up on the wrong side. Each stream has a grade: F for the feed, C for the concentrate, T for the tailings. The grade is just the fraction of valuable in that stream. Two balances describe this system. First, the solid balance, feed equals concentrate plus tailings. Second, the component balance, the same balance but for the valuable mineral, F times F equals C times C plus T times T. This is the two-product formula. From here, everything else follows. We don't always know the tonnages. Often we only have the three grades. So let's get rid of T. Substitute T equals F minus C, expand and group the terms, and we land on the mass yield. C over F equals F minus T over C minus T, the fraction of feed that reports to concentrate. From that one result, a whole family of formulas appears. Recovery, the percentage of valuable mineral actually captured. The concentration ratio, key, how many tons of feed make 1 ton of concentrate. And the enrichment ratio, E, how many times we've raised the grade. Let's use them. A chromite plant, feed grade 8.2%, concentrate 45.4%, tailings 1.6%. Mass yield comes out to 15%, recovery 83%, the concentration ratio is about 6.5, so 6.5 tons of feed per ton of concentrate. And the ore is enriched about 5.5 times. The same formula works for water. A hydrocyclone fed at 45% solids, overflow at 32, underflow at 70. The trick, we don't use percent solids directly. We convert to water to solid ratio first, then it's the exact same yield formula. The result is striking. 53% of the solids go to the underflow, but only 19% of the water. That's exactly what a cyclone is for. And it works for particle size too. A spiral classifier, feed at 52% passing 300 microns, overflow 96, underflow 31. Same formula, and about 68% of the feed reports to the coarse underflow. One caution: don't trust a single size, calculate for several sizes and take the average. So there it is. One law, conservation of mass, gives us the two-product formula. And from it, yield, recovery, concentration and enrichment. The same tools for metal, water and size.